Hello students, chapter 2 start chapter. How much does a curve? Chapter title. So curve means curve. So the first curve is used as noun and the second curve is used as verb. So for example, to get some motivation, look at a straight line. Does this curve? No. So if a curve curves, then we assign a numerical quantity to that which measures how much it curves. So that is going to be called as curvature. Since straight lines do not curve, curvature of straight line must be equal to 0. And look at concentric circles. Take unit arc length on the smaller circle as well as on the bigger circle. In unit arc length, smaller circle curves more than that of the bigger circle. So the curvature of the smaller circle should be greater than that of the curvature of the larger circle. So if the radius of the circle becomes very large, for example like the radius of Earth or Sun, we will not feel that there is a kind of curvature at the point where we are standing. Now come to this curve. Now look at the unit arc length. At this point, the curvature is more. At this point also the curvature is more. But here at this point the curve turns to the right, and at this point the curvature turns to the left. And at this point the curvature is less compared to these points. So how do you measure curvature? So the intuitive idea is to look at the tangent vectors per unit length. So draw a tangent vector here. I will use yellow color. Tangent vector at this point, tangent vector at this point, tangent vector at this point, tangent vector at this point. So the tangent vector turns. Now look at this portion of the curve. Tangent vector here, tangent vector here, tangent vector here, tangent vector here. So tangent vector again turns. Now look at this portion of the curve. Tangent vector here, tangent vector here. Here also tangent vector turns, but not that much fast. So if the curvature is more, then the tangent vector turns fast. So let us take unit tangent vector. So there is some kind of change for the tangent vector. That means we have to measure the rate of change of the tangent vector. If we are taking unit tangent vectors, then there is no change in the magnitude. There will be change only in the direction. Therefore, what is tangent vector? If gamma is a parameterized curve, then gamma dot of t represents tangent vector at the point t. This is the tangent vector at the point gamma of t. And you want to measure the rate of change of this tangent vector. That means you want to measure the derivative, gamma double dot. Gamma double dot is actually acceleration. and you want to see how much the tangent vector changes with respect to time in its direction. So gamma double dot of t probably can measure the curvature of the curve at the point gamma of t. Okay, so this is the intuitive idea. Let us take a curve, parameterized curve gamma of t. This is the point gamma of t. This is the point gamma of t plus delta t. This is the vector gamma of t plus delta t minus gamma of t. This is the point P. This is the point Q. Okay, I will consider a unit vector at the point P. Normal to, that means perpendicular to the tangent vector. This is the tangent vector at the point P. So this is the unit vector N. And if this point is Q, no, control Z. This is the unit vector N, and here you have the tangent vector PR, and I want to measure how much the vector PQ deviates from the tangent vector PR. That means I want to measure this distance. Okay, this point P I will write here. This is the point P. Yes. P is the point gamma of t. What is PR? PR is actually, from this figure, it is this vector PQ dot n. PQ dot n. So what is PQ? It is gamma of t plus delta t minus gamma of t dot product with n. Now use Taylor's theorem. So gamma of t plus delta t equal to gamma of t plus delta t equal to gamma of t plus gamma dot t into delta t plus gamma dot 1 by 2 factorial gamma dot t, gamma double dot of t into delta t whole square plus higher terms in delta t. Okay. Therefore, gamma of t plus delta t minus gamma of t will be gamma of t plus delta t minus gamma of t will be therefore gamma of t plus delta t minus gamma of t will be gamma dot of t into delta t plus 1 by 2 factorial gamma double dot of t into delta t square plus higher terms. Now let us take dot product with this n. So what I will get? I will use a different color. Gamma of t plus delta t minus gamma of t dot n, which is my PR. That means deviation of the vector PQ from its tangent. No, this PR is, it's not PR, it is PQ. No, it is RQ. This much is this dot product. I am sorry for that. So RQ. RQ length. So absolute value of this. Here also absolute value. So this is equal to gamma dot t dot product with n. What is that? 0, because gamma dot t is tangent vector and n is normal vector. So remaining is 1 by 2 factorial gamma double dot of t dot vector n into delta t square plus higher terms dot product with n. Dot product with n. Now when delta t is small, you can neglect these higher terms. Neglect. So this deviation is how much? 1 by 2 factorial gamma double dot of t dot product with n delta t square, and if you take norm of this, you will get norm of n will be equal to 1 because n is unit vector. You will get 1 by 2 factorial norm of gamma double dot of t times delta t square. Okay. So therefore, this deviation can be measured in terms of the second derivative, gamma double dot of t. So that is the idea. Therefore we define for a curve the curvature at a point gamma of t. So definition, the curvature at the point gamma of t. So assume that gamma is a regular curve. So my assumption is gamma regular. Gamma is unit speed. My assumption is gamma is unit speed. The curvature at the point gamma of t is defined as norm of gamma double dot of t. We will see one or two examples. Suppose gamma is a straight line. Gamma of t is equal to a plus tb, where a and b are vectors, t is scalar. So this vector passes through the point A and parallel to another vector b. So what is gamma dot of t? Gamma dot of t is vector b, and gamma double dot of t is the zero vector. So norm of curvature. Curvature is denoted by the letter kappa. Curvature is denoted by the letter kappa. So what is kappa? It is norm of 0, which is equal to 0. So the curvature of a straight line is 0. Let us do another example. We take a circle of radius r centered at the origin in R2. Radius is r. So what is the parameterization? There is what is a parameterization? Gamma of t equal to r cos t, comma r sin t, what is gamma dot velocity? Velocity is equal to minus r sin t. Oh, the thing is that this gamma is not unit speed. So let me make this unit speed. So r cos t by r sin t by r, this will be a unit speed curve. Is it so? Because gamma dot t in this case will be minus r sin t by r into 1 by r. Sin t by r into 1 by r, comma r sin t by r, sorry, cos. R cos t by r. What is derivative of t by r? with respect to t, it is 1 by r. So this r get cancelled, this r get cancelled. So what is gamma dot t? It is minus sin t by r cos t by r. This is the velocity. Clearly, norm of gamma dot is equal to 1. Therefore, gamma is a unit speed curve. Now, what is gamma double dot? Gamma double dot of t is equal to 1 by r minus cosine t by r, comma, minus sin t by r into derivative of t by r is 1 by r, with a minus sign here. What is kappa? Kappa is equal to norm of this vector, so it is 1 by r. So as expected, when r increases, kappa decreases, and when r decreases, kappa increases. So larger circles have smaller radius and smaller curvature, and smaller circles will have larger radius of curvature. Thank you.